Space exploration. The possibilities for discovery are limitless. A vast collection of celestial knowledge has been gained since the dawn of solar system exploration, sparking new questions in a quest to learn where we came from and where we are destined to go. In NASA's Discovery program, scientists venture deep into their imaginations, finding innovative ways to unlock the mysteries of our solar system by answering some of humanity's oldest questions. How did the planetary bodies and cosmic structures form and evolve? How did we get here? Where are we going? And do other life forms exist elsewhere in the universe? Or are we alone? The Discovery program represents a breakthrough in the way NASA conducts space exploration, launching more frequent, lower-cost missions. Discovery's main objective is to enhance our understanding of the solar system, both past and present, by exploring the planets, their moons, and other small celestial bodies. Discovery missions are competitively selected through an extensive peer review process. A principal investigator for each mission develops science objectives and an instrument payload, selects team members, and assures that cost, schedule, and performance objectives are met. Teaming arrangements among NASA centers, universities, industry, and other organizations are encouraged, thus combining the necessary skills and expertise to carry out a mission from concept development through data return and analysis.
A little more water on top of it? Ladies and gentlemen, we have a comet.
Discovery is one of the first NASA programs to require that mission proposals include a comprehensive education and public outreach plan in order to communicate NASA's vision of bringing the excitement of space exploration to the public. Discovery is reaching students of all ages with innovative methods that support national education initiatives. 10 Discovery missions have been selected since the program's inception in 1992. Half of the missions explore and investigate unique aspects of small, primitive solar system bodies, the asteroids and comets. The icy and rocky comets were formed 4.6 billion years ago, at the same time as the 9 planets began to take shape. Cometary ice may have played a role in forming our oceans and atmosphere. Asteroids, rocky and often iron-rich minor planets that are devoid of atmospheres, range from pebble size to almost 1,000 kilometers in diameter. Yet the mass of all solar system asteroids is barely equal to that of our moon. Asteroids and comets have changed very little since their formation and offer scientists a close-up look at the primordial elements from which Earth and the other planets were formed. Each Discovery mission will add a new piece of knowledge to help solve the cosmic puzzle. Discovery's first mission to depart Earth, the Near-Earth Asteroid Rendezvous, or NEAR mission, was destined for Eros, the largest of the near-Earth approaching asteroids. Eros became a celestial laboratory for scientists to answer many fundamental questions about the nature and origin of asteroids, a primary mission goal. Each of NEAR Shoemaker's 6 science experiments contributed in different ways to understanding the structure and composition of Eros. Instrument data, including over 160,000 images returned during the year-long orbit, have revealed Eros to be a cracked yet solid rock with a density similar to that of Earth's crust. Scientists now believe that Eros formed as a chip off a larger asteroidal body. Within days of completing 1 year in orbit and after achieving all of the planned science goals, the mission team programmed NEAR Shoemaker to descend and land on the surface of Eros to gain even more data at smaller scale.
Yep. Okay, we got our first image.
The spacecraft was not designed to be a lander. the highly risky yet carefully planned maneuver successfully set the spacecraft down near Himeros, Eros's prominent saddle-shaped depression. Scientists from around the world are now studying the vast treasure trove of data from the NEAR mission. Data that is revealing many new and surprising details about asteroids. And with new data come new questions waiting to be answered by future Discovery missions. A journey in both space and time is planned for one of Discovery's most recently selected missions. Dawn will travel to the donut-shaped asteroid belt between Mars and Jupiter. There it will conduct a detailed close-in study of Vesta and Ceres, two of the first known and most massive solar system asteroids. Studying the surface and internal geology of these two primitive minor planets with the same set of instruments will give scientists a snapshot of conditions present during the first 10 million years after the genesis of the solar system. Chief among the goals is to determine the shape, size, composition, internal structure, and the tectonic and thermal evolution of Vesta and Ceres. Comparing the different evolutionary paths of Ceres and Vesta will provide evidence about the role of size and water in planetary evolution. Dawn is the first purely scientific mission designed to be powered by ion propulsion, an advanced technology successfully demonstrated in 1998 by NASA's Deep Space One mission. Ion propulsion will, for the first time, enable Dawn to orbit and study two asteroids during one mission. The spacecraft arrives at Vesta 4 years after launch in 2010, and Ceres 4 years later. Discovery's asteroid missions are bringing humankind closer to answering the many unanswered questions about our origins. Comets, like asteroids, also contain clues to our origins. Each of Discovery's comet missions will greatly increase our understanding of comets in very different ways. As its primary goal, Stardust, NASA's first exclusive comet-exploring mission, will venture into the solar system to collect and return extraterrestrial material to Earth. Stardust's cometary dust-collecting encounter with Wild 2 in January 2004 will take the spacecraft through the coma cloud of dust and gas from as close as 150 kilometers ahead of the comet's nucleus. On its way to Wild 2, Stardust will have two bonus science opportunities to collect interstellar dust particles smaller than a grain of sand, thought to have originated from distant galactic stars. Mission engineers have designed a tennis racket-sized collector grid using an extraordinary substance called aerogel. Aerogel is a silica-based solid that is 99.8% air and 1,000 times less dense than glass, the lightest known solid as listed in the Guinness Book of World Records. Aerogel's amazing properties allow the collector grid to capture the tiny cosmic particles without altering their shape or chemical composition. In early 2006, Stardust returns to the Earth, ending its 4.8 billion kilometer sojourn through the solar system. The return capsule containing the cosmic samples will be jettisoned back through Earth's atmosphere to be retrieved by mission team members at the Air Force Test and Training Range in Utah. The Stardust mission offers the worldwide science community a unique first-hand opportunity to analyze the earliest materials that created the solar system, all part of a continuing quest to discover the building blocks of life on Earth. Studying two very different types of comets at extremely close range was the goal of Contour, the Comet Nucleus Tour, Discovery's second comet-dedicated mission. Mission scientists expected high-resolution images to reveal distinguishing features that would unravel the different evolutionary processes of comets from the time of their formation in interstellar space to their fiery close encounters with the Sun. The comet-chasing Contour was to cross the dense, dusty coma at the heart of comets Encke and Schwarzmann-Bachmann 3, approaching to within 100 kilometers as each nears the Sun. As its primary goal, Contour planned to collect and analyze comet dust, and using remote sensing instruments, measure the chemical composition in order to dramatically improve our knowledge of key comet nuclei characteristics. Contour's dual comet mission was to delve into the heart of comet diversity, affording scientists an opportunity to fill in the gaps of cometary knowledge. Unfortunately, contact with the Contour spacecraft was lost on August 15, 2002, following an otherwise routine maneuver to propel the spacecraft into its comet-chasing solar orbit. At the time, Contour was about 225 kilometers above the Indian Ocean and out of radio contact with controllers. The Contour mission operations team expected to regain contact soon after the burn, but NASA's Deep Space Network antennas did not acquire a signal. Since then, there has been no contact with Contour. The first attempt to intentionally probe deep beneath the surface of a comet in order to expose its inner secrets is the astonishing mission of Deep Impact. The two-part Deep Impact spacecraft will eject its smaller impactor section at 10 kilometers per second into the path of Comet Tempel 1 for a highly targeted collision. Impacting with the kinetic energy equal to 4 tons of TNT will create a football field-sized 7-story deep crater. Ice and dust will be ejected from the crater, exposing fresh, never-before-seen material from the comet's core. A camera on the impactor will capture and relay images of the comet nucleus just seconds before it collides with the comet. Cameras on the spacecraft's larger flyby portion will send back images to Earth of the approach, impact, and aftermath. The Deep Impact collision will also be observable from certain locations on Earth by professional and amateur astronomers, and the results webcast over the internet. Mission images will be analyzed, and together with the knowledge gained by Discovery's other comet missions, will contribute to a better understanding of the solar system's formation and the implications of comets colliding with Earth. Ions from the Sun and the Moon are targets for 2 other Discovery missions. After a 5-day transit to the Moon, Lunar Prospector, Discovery's 3rd mission, began a 19-month global study of the Moon's surface, providing insights into lunar origin and evolution, while also attempting to determine whether water ice is present in the Moon's polar regions. A wealth of data collected by the 5 spacecraft instruments from a near-circular lunar polar orbit of 100 kilometers above the surface has enabled scientists to create the most detailed maps of the Moon's gravity, magnetic properties, and chemical composition. Upon completion of its mission in July 1999, scientists targeted the spacecraft for an impact inside a shadowed crater near the lunar South Pole. If water ice existed on the Moon's surface, the impact would free up water vapor that might then be detectable from Earth-based observatories and the Hubble Space Telescope. Although the controlled crash produced no observable evidence of water, analysis of neutron spectrometer data confirms previous indications that hydrogen at the lunar poles is in the form of water ice. Lunar Prospector has given scientists tremendous new insight into Earth's closest celestial neighbor, the Moon, and provided a greater understanding of solar system origins that has expanded our horizons.
NSC report spacecraft is go.
Genesis is go for launch.
We have ignition, and we have liftoff of NASA's Genesis spacecraft on a mission to retrieve a piece of the Sun.
Scientists generally believe bodies in our solar system formed 4.6 billion years ago when interstellar gases, dust, and ice randomly came together. Outer layers of the Sun today are composed of nearly the same material as when it was first created. What if we could capture pieces of this solar material and study it here on Earth? That is the goal of Genesis, a mission to collect ionized gas from the Sun called solar wind and then return it to Earth. Mission scientists hope to learn what the Sun is made of, and if the planets are made of the same materials. For 26 months, Genesis will orbit 1.6 million kilometers from Earth at the L1 libration point, where the gravitational forces of the Earth and Sun are balanced. Genesis will collect ions from the solar wind on specially designed high-purity wafers. At the mission's end, the spacecraft will return to Earth, sending the sample return canister down to the Utah Test and Training Range to be captured by a helicopter in midair to prevent any damage to the precious cargo. The Genesis samples will be the first solar system material returned to Earth since Apollo. The samples will be stored and cataloged under ultra-pure cleanroom conditions in a facility built especially for Genesis at NASA's Johnson Space Center. Genesis will provide a supply of solar matter for 21st century science research to enrich our understanding of the birth and evolution of the planets and other bodies in our solar system. 3 Discovery missions target planets: Mars, Mercury, and a search for Earth-sized planets orbiting other stars. With NASA's first return to the Martian surface in more than 20 years, Mars Pathfinder performed science experiments on the surface of Mars for nearly 3 months, achieving its primary objective of demonstrating a low-cost method of delivering a set of science instruments and a small rover to the surface of the red planet. Rock and soil samples at the landing site were analyzed, atmospheric and weather conditions were monitored, and Pathfinder conducted the first astronomy studies from the surface of another planet. After a 6-month journey, a unique engineering design sent Pathfinder through the thin Martian atmosphere, descending to the surface of Mars, using an innovative system of parachutes and retro-rockets to slow the lander. And then, shrouded with an inflated beach ball-like airbag, free-falling for the last few hundred feet, bouncing as high as a 10-story building due to the low Martian gravity. Once deflated, the airbag opened a path for the Sojourner rover to explore and analyze nearby rocks. Mars Pathfinder returned more than 16,000 images from the lander and 550 images from the rover. The science teams analyzed extensive data about the planet's geology, magnetic properties, mineralogy, and geochemistry. The new information about the Martian interior will help scientists to understand how the red planet has evolved over billions of years. Mars Pathfinder has played a crucial role in advancing NASA's long-term plan for Mars exploration and other Discovery planetary journeys. Almost 3 decades have passed since Mariner 10 flew by the planet Mercury on a mission that mapped only 45% of the planet's surface. Discovery's lower-cost Messenger mission will continue the legacy of Mariner 10 with a comprehensive scientific investigation of the solar system's innermost planet. During its 5-year trip to Mercury, Messenger will perform 2 gravity-assisted flybys of both Venus and Mercury, collecting atmospheric and gravity measurements of Mercury along the way and capturing never-before-seen images of the planet. In September 2009, a second mission phase begins. Orbiting for 1 Earth year or 4 Mercurian years, the spacecraft will globally map and perform a detailed characterization of the surface, interior, atmosphere, and magnetosphere of the planet. The spacecraft's 7 miniaturized instruments will collect data to answer key scientific questions about the origin of the planet's high density, the composition of its crust, the existence of volcanism on the planet, whether hydrogen in water ice exists in the polar caps, and if a liquid outer core is responsible for generating its Earth-like magnetic field. Messenger will provide an understanding of the thin Mercurian atmosphere, its dense rocky geology, and the forces that have shaped Mercury, all fundamental to understanding the terrestrial planets and their evolution. Exploring the evolution, structure, and diversity of planetary systems is the goal of Kepler, a discovery mission to search for Earth-sized planets around stars in our galactic neighborhood. Using newly developed technology, the mission expects to detect hundreds of planets in or near the habitable zones surrounding stars. Detecting extrasolar planets from a very stable heliocentric Earth-trailing orbit around the Sun, Kepler will observe habitable zones in regions where water can be expected to exist in liquid form, increasing the probability of life. Kepler will greatly increase our understanding of planetary formation, the structure of individual planetary systems, and the generic characteristics of stars with terrestrial planets. The Kepler mission may help us answer one of the most enduring questions humans have asked throughout history. Are there others like us in the universe? NASA's Discovery program has achieved groundbreaking science within strict cost and schedule caps.
I believe I have a firm signal.
The President and I are both very, very proud of your accomplishments, and the entire country is just reveling in your success, and we all congratulate you.
Discovery is demonstrating that simple, focused missions can pay rich dividends while driving new, innovative technology, with the ultimate prospect of improving life on Earth. Discovery is unlocking the mysteries of the solar system.